Hi, hello everyone. मेरे प्यारा बच्चा लोग कैसे हैं सब? And how are you all doing? I missed every one of you. Let me tell you that. And what about you all? Miss किया ना सब लोग? हाँ? ठीक है. Now those who are seeing me for the very first time, this is Amir, your physics teacher at Extramarks, and those who love me more, they simply call me Amir Bhaiya, isn't it? So tell me, क्या चाल? And let me say hi to everyone over here. Chandrasekhar, Preeti, Dhruv, Eddie Junction, everyone. Hi, hello everyone. सब बढ़िया है ना? ठीक है, ठीक है, ठीक है. And welcome to another session of Strate-JEE. Now let's see what we are going to do in this amazing session of Strate-JEE. ठीक है. Now here we'll be mainly discussing the previous year questions. And what is the use of discussing the previous year questions? The main thing is that if we discuss all these questions, we can have a better idea how the question is going to be. What is the pattern of each and every question papers, right? And based on that, we can make the perfect strategy for our study plans, right? We can easily understand what all kind of questions and what all level of questions we have to choose while doing the preparation for JEE. So many amazing things. And if we make the preparation like this, and if we go and write the demo test, what happens, right? Obviously, we can get a positive attitude towards the examination, and that is exactly the motivation to crack JEE, right? Not just that you can see amazing things that you're going to gain through this strategy. So you can see study plans, obviously we already have mentioned. We can actually understand the weightage of each and every chapter, because in this series we'll be actually taking each and every chapters. Let's say electrostatics already done. Today in this class we'll be doing the chapter of current electricity. So by knowing the number of questions from this particular chapter, that will help you to know that what is the weightage of this particular chapter for the JEE examination. Obviously you can make the study plans accordingly, right? And solve the questions with smart array. If you keep on solving the questions to the level of JEE, you can get to know what all tips and tricks that you can use to solve these questions, isn't it? Right? That is nothing more than that, an error analysis. By writing all these examinations and by doing the questions of previous year, you can actually understand, right, which are the portions where you have most probability of making the errors, right? So during the main examination time, you can actually avoid it. Matlab, after sitting here in the session, you are going to go away from the session with so many amazing things over here. Right? Hi Sachin, good evening, सब बढ़िया है ना? Okay. Now, those who are seeing me for the very first time, you will be asking, okay, what he did and what's his qualification, right? I'll tell you, I did my BTech from NIT Calicut in mechanical engineering, and yes, I have a teaching experience of 4 years. And let me add one more thing. I'm from Kerala. So, I don't know Hindi much, but I'm here in Extramarks and I have so many colleagues from this North Indian part. Though they make fun of me about my Hindi, I'm still improving in the language, ठीक है? So बीच में थोड़ा हिंदी में भी बातें करेगा, right? Okay, then about Extramarks, if we talk about 1 out of every 7 Extramarks students are selected in JEE Main 2021. Okay, and don't worry, we are going to improve the number like anything, and I want every one of you to be a part of that, right? And regarding the content what we're going to provide, don't worry at all, because it is being designed by experts from IITs and NITs. Okay, so moving on. You know, we'll be discussing the questions from the chapter of current electricity, which actually have appeared for all JEE examinations, right? What are the main topics that we'll be stressing in this particular session? Ohm's law, which we all are familiar with, combination of cells, electric power, Wheatstone bridge, potentiometer, and Kirchhoff law, right? So if you all give me a very amazing hi from there, let's start with the session. Who all are here? Hi Raktim, hi, hey, hi Isra. Okay, thank you so much. Myara, hi Myara, good to see you again. Rahul, hi. Preeti, welcome back. Thank you so much, right? I'm so happy to know that I'm still there in your hearts, okay, with all the love. Let's start with the very first question, right? So here we go. Let's read the very first question over here. In the figure given, the electric current flowing through the 5 kilo ohm, I hope you all have noticed the 5 kilo ohm resistor over here is X milliampere, which means we are asked to find out the value of X, which means the value of current that is passing through this 5 kilo ohm. Now you all know the drill, right? Because many of you already have attended my class. How do we solve? I'll be solving the question over here, and during the time, take out the pen and paper and keep on solving the questions and give me the answer as fast as possible in the chat box. I'll be looking for your answers in the chat box, okay? Everyone, don't be lazy out there. Right? Okay, so let's solve it. Now, the question is mainly to find out the value of current passing through the 5 kilo ohm, right? Yes or no? Yes or no? Yes, which means through this particular. Let's mark it as I. Okay. Now tell me, Is this current the net value of the current passing through the circuit? Exactly. So the net value of the current passing through the circuit can be written as I is equal to V divided by R, and R is the net amount of resistance. We already given, which is 21. Can't we just find out the equivalent value of resistance? Obviously. Let's do it, right? We have 3 kilo ohms and 3 kilo ohms in parallel. How can we calculate the equivalent value of resistance of this 3? We'll do it here. R equivalent, what's the formula? If we have n number of resistors of equal value connected in parallel, R by n. So here we have 3 kilo ohms. So 3 kilo ohms divided by number of resistors is 3. So 3 by 3, that is equal to 1. Right? Okay. ठीक है. बढ़िया बात है. So इधर हमारा पास है 1 kilo ohm. This 1 kilo ohm will now be connected with 5 kilo ohm. In what fashion? Series. 5 plus 1, 6 हो गया. And with this 6, देख ले, एक और resistor है हमारे पास, which is the internal resistor of the cell that also has to be counted. Don't make a mistake over here, ठीक है? So 5 plus 1 हो गया 6, 6 plus 1 हो गया 6 plus 1, 1, 2, 3, 4, 5, 6, 6 plus 1, 7, right? So yes, 7 kilo ohm is the net value of resistance. So what is left? कुछ भी नहीं, just substitute the value. That is 21 divided by 7 kilo ohm. Don't forget to put 10 power 3 out there. 21 by 7, 3 into 10 power minus 3 amperes, which is equal to 3 milliamperes. X का value कितना है? X का value कितना है? X का value here is 3 milliampere, right? Obviously X is equal to 3 because it is said in the question that the amount of current passing through this particular 5 ohm is X milliampere, and we actually find out the value as 3 milliampere. So the value of X is equal to, without any further doubts, we can actually write X is equal to 3. कोई दिक्कत? कोई problems? No, right? And I think everyone is lazy out here. Where are your answers मेरे बच्चा लोग? कहाँ है आप लोगों का answers? Is it because my net is going slow, or is your calculation going slow out there? No? Yes? Yes? No? Hi Diksha, hello, good to see you over here. Sab badhiya hai na? ठीक है. Now moving, okay, so here is the answer. Don't forget to mark the answers, okay? And if you still have any problems here and there with the concept that we have discussed, don't forget to go through the question once again. ठीक है ना? बढ़िया. अगला question, here we have. Okay, so this is a question from combination of cells. Be alert, okay? And question from 2021 JEE main. ठीक है, जा रहा हूँ. 2 cells we have, EMF 2E, okay? And the other one with E. Internal resistance, though it is not marked in the figure, you have to know that there is internal resistance for each of them, R1 and R2 respectively, are connected in series to an external resistor R over here. देख सकता है ना? ठीक है. The value of R, which the potential difference across the terminals of the first cell becomes 0. We have to find out that value of the resistance so that the potential difference across the first cell, here the EMF of the cell is 2E, right? At what value of R, the potential difference across the first cell is going to be 0. ठीक है, चलेगा. Let's find out. So I'm going to mark the potential difference over here as V. Should I change the color of the pen? ठीक है, let's change it, right? हमको choose करेगा कौन सा चाहिए हमके? हम ढूंढेगा yellow. Let's see how yellow is working over here. ठीक है. Okay, now first tell me what is the basic equation? अरे yellow तो काम नहीं हो रहा है, तो और use करेगा red. ठीक है. Let's see कैसे red कैसे. ठीक है, red तो अच्छा चल रहा है. So tell me what is the equation to find out the potential difference? V is equal to, yes, the net value of EMF minus the net value of current into the internal resistance R, right? Okay. Tell me which cell we are talking about. We are talking about the first cell. What is its EMF? 2E, right? So let me put it as 2E minus I into what is its internal resistance. Obviously, the first cell is having an internal resistance of R1. It is given in the question, right? ठीक है. Now, what is left is to find out the value of I. कैसे? How can we calculate the net value of current passing to the circuit? Very simple. अरे current का value total EMF by total resistance, right? Total EMF कितना आता है? अरे 2E. E, 2 cells in series, add कर ले 2E plus E, how much? 3, ठीक है? So 3E, ठीक है, let us substitute. Minus current is equal to EMF, that is equal to 3, we already have told, divided by total resistance. Is total resistance R? मारेगा मैं सबको. Is total resistance capital R? नहीं. We also have R1 and R2, internal resistance R1 and R2, all are connected in what fashion? Parallel fashion or series fashion? Series fashion, right? So R1 plus R2 plus capital R. So total resistance is equal to R plus R1 plus R2 into R1. हो गया. ठीक है. Now it is given in the question that we are asked to find out the value of R at which the potential difference becomes कितना? 0. So ले 0. Common क्या है? E common है from both the sides. So cancel it off. So taking this 3e to the left hand side. So 3r1 divided by r plus r1 plus r2 is equal to 2. ठीक है. बढ़िया. Now what I'm going to do is we are going to multiply this to the right hand side. So 3r1 is equal to 3r1 हो गया 2 capital R plus 2 small r1 plus 2r2. ठीक है. So 3r1 minus 2r1 हो गया इधर r1 minus 2r2 हो गया that is equal to 2r. So r का value rearrange कर ले, take this 2 to the denominator. So हो गया r1 by 2 minus r2 and हो गया हमारा आंसर. इससे ज़्यादा क्या चाहिए? Right? I hope you all got it. Yes or no? Yes or no? Yes or no? जल्दी बता दे यार. This is not the energy what I'm expecting from every one of you. That Joe should be there from everyone, right? Right, Janani. Calculation going slow. You have to speed it up, right? You have to put it on the pace because during the JEE examination time, you also know that उतना तो time नहीं मिलेगा यार. ठीक है. So जल्दी से जल्दी, ठीक है, pace बढ़ा दे. So our answer is R1 by 2 minus R2. I hope you all got the correct answer. ठीक है ना? अगला question पे आ गया हम. So yes, let's solve it. Here we go. In the experiment of Ohm's law, a potential difference of 5 volt is applied across the end of a conductor of length 10 centimeter and diameter of 5 millimeter. The measured current in conductor is 2 ampere. सब दे दिया. Potential difference, current, length of the conductor, diameter of the conductor. पूछना क्या है इधर? The maximum permissible percentage error in the resistivity of the conductor. So while all these calculations are being made for that particular conductor, right? How much can be the error that can occur in the calculation of resistivity? ठीक है. So first let us make an equation for resistivity. Tell me what is the basic equation for resistance? R is equal to V divided by I. है ना? Tell me what is the equation for resistance in terms of resistivity. वो होता है rho L divided by A is equal to V divided by I. Right? है या नहीं? हाँ. So we just need to rearrange and do the calculation. That's it. So rho is equal to V divided by I. Tell me what is the value of area with respect to diameter? That is pi by 4 d square, right? So वो हो गया pi by 4 d square divided by L. ठीक है, बढ़िया. हो गया. Okay. From this particular chapter of current electricity, whatever we are supposed to write, that is done. Now it's all from units and dimensions chapter and error analysis. So the question is to find out the error. Tell me what was the equation to find out the error here. Delta rho by rho is equal to delta rho by rho into 100 is equal to, it's going to be bigger. ठीक है. So I'll be writing in the next line also. ठीक है. So we have, so that is going to be delta V by V into 100 plus I we already have discussed in the chapter, in the 11th standard, though it is in the denominator, it will be coming with plus because errors always get added up. है ना मेरे बच्चा लोग? So ठीक है. So we have delta I by I into 100 plus, I'm going to write it at the bottom. ठीक है. Then we have pi by 4 constant, no errors will be there. D square, there is a power, it has to be multiplied, delta D by D into 100 plus last one L we have, so it is delta L by L into 100. हो गई बात. ठीक है. Now we just need to substitute the values here. Now you can see delta V, which is the error in the calculation of potential difference. Delta I is the error in the calculation of current. So how to get all these values? Simple thing I have to remind you, because for every calculation, the minimum possible error in the calculation or in the measurement is the least count of that particular instrument, right? So you can see in the calculation of potential difference, where do we have potential difference? Everyone, yes, 5.0 volt. Tell me what is the least count of this particular instrument or this particular voltmeter? That is 0.1, because 5.0, 0.1 has to be the minimum value that can be calculated with this above given voltmeter, right? So delta V हो जाएगा 0.1 divided by what is V, the actual value, that's 5, ठीक है, into 100 plus delta I, error in the calculation of current, where do we have 2.00, minimum value 0.01, 0.01 divided by 2, isn't it? Yes, into 100 plus, और क्या बाकी है 2 times delta D, error in diameter. Where is diameter? Where do we have that? Is 0.01 once again. So 2 times 0.01 divided by 5 into 100 plus. What else? Where is the error in length? Arey bahut sara. So many things you've written over here, right over here, right? So 10.0, it's 0.1 is the error in the calculation of length divided by 10 into 100. So you guys are pretty fast in calculation than me, right? So zoom. If I do the calculation, how much we're going to get it here? Right, after the calculation, we're going to get the value of 3.9 over here. So yes, I'm going to write the value directly, 3.9, and the calculation I'm leaving it to every one of you. Don't do it on calculators, okay? Because you know that for JEE mains examination or JEE advanced level, you can't take the calculator inside. ये होना चाहिए आप लोगों का calculator, ठीक है? So yes. So हो गया ना सबको? Tell me. After how many questions we have done? 2 questions, I suppose, right? So tell me, are all the concepts clear? Yes. Tell me, are all the concepts clear? Yes, hi Arya, hi Sudeep. Everyone is over here. I hope the concepts are super clear to every one of you and the answer is also clear. Don't forget to do it once again after this class, ठीक है? So हम जा रहे हैं कहाँ जा रहे हैं? अगला question पे, ठीक है? ये तो simple question है compared to the question that we have done till now. A current through a wire depends on time as I is equal to alpha naught t plus beta t square, where alpha naught is equal to 20 ampere per second, ठीक है? Beta is equal to 8 ampere per second square. Then find the charge cross through a section of the wire in 15 seconds. Current का formula दे दिया है and question क्या पूछ लिया? Question पूछ लिया है कि charge का value कितना है? So yes. Sir, can only a CBSE board students can take this class? अरे बिल्कुल नहीं प्रीति, it's Strate-JEE and we are discussing JEE mains, previous JEE mains questions, right? So whoever is preparing for JEE examinations, right? You are the best people to be here because we are going to train you in the best way possible, ठीक है? Yes. So yeah, let's proceed. Hello Anubhav, good to see you over here, right? ठीक है. So question हम पढ़ लिया. What we have to find out? Charge, isn't it? And how to get charge from current? अरे लिख ले everyone. I is equal to dq divided by dt. हो गई बात? Rearrange कर ले. Find out the value of charge. Tell me dq. Okay. dq value, the small change in charge is equal to, rearrange करने, I dt. Do we need the small change in charge? No, we want the entire charge. So we have to integrate. Right? So integral of dq will give us q and integral of I dt from where to where? From a time of 0 to a time of 15 seconds we have to do it. Right? So ठीक है. What I'm going to do? I'm going to substitute for I. I का value alpha naught t plus beta t square into dt integral 0 to 15. हो गई बात? Right? Okay, anybody who is strong enough to give me the answer within this time? I'm not able to see the answers from every one of you. Big fan of your Anubhav ji, thank you so much. बिल्कुल बढ़िया. ठीक है. अरे good evening Chandrasekhar. So what is left to complete this particular question? अरे integrate करना है ना? ठीक है. How's my Hindi by the way? I think I have improved, right? Okay. ठीक है. So alpha naught t dt, so that is equal to t square divided by 2 plus beta t square integral t cube divided by 3 कितना कहाँ से 0 to 15 तक. Right? Now we can just substitute the values. Tell me, alpha naught का value दे दिया 20. So 20 by 2 हो जाएगा 10. Right? 10. Now when t takes the upper limit, which is 15 square हो जाएगा 225. So this is 225 plus how much it is? Beta is given as 8. So 8 by 3. 8 divided by 3 into t, 15 the whole cube. Right? Calculation. As you all know, you guys are the super best in doing the calculation, right? So, If we do the calculation, how much is the charge we're going to get it? 11250. So let me write it over here. 11250 coulomb is the amount of charge that will be flowing through this particular given wire in a time of 15 seconds. How much is it? 11,250 coulomb. Awesome, amazing, right? So yes, let's proceed. Yes, I do remember you, Evelyn. Because we all used to have amazing classes, right? Okay. So anyway, the answer, I hope it is pretty clear to every one of you, isn't it? Right? Okay. Let's move to the next question, and this is one of the simplest questions, though the figure finds a bit difficult for every one of you. And what do we have, sir? Please, we need some one-shots for our board exams, please, for us. Please, let me try. Okay. Okay. So let us proceed with this particular question and let's solve it out. Okay, here we go. 5 equal resistances, as you all can see, all are with the same value of R. Connected in a network as shown in the figure, the net resistance between the point A and B is, right? Between the points A and B, if we look, what is the equivalent value of resistance? I know that. When you start looking at this particular figure for a longer amount of time, it looks more and more complex. So do you think we just need to redraw this figure? What do you all say? What do you all say? What do you all say? Right? Evelyn, you don't have to spam. I have actually seen your message. Okay, we'll take that into consideration and we'll try to solve the problem as soon as possible, right? If we are coming with such a kind of a series, I'll let you know for sure. Don't worry at all. So what we have to do over here? We have to solve this question. Between the points A and B, we have to find out the equivalent value of resistance. Kaise? We'll mark all the points over here and we'll try to redraw the figure. So we have A, we have B, right? C, we have D, we have, so we'll mark this particular point as E over here, right? And let's start redrawing. Starting from the first point, that is point A, right? So we have the point A. From the point A, 2 resistances are diverted. Okay, one resistance we have, another resistance we have, right? Okay, so one of the resistance goes to the point D, let's say, other goes to the point E, let's say. Now the point D and E are connected by a resistor R over here, right? So point D and point E are connected by a resistor over here. वो भी हो गया. अब बाकी क्या है? Now from E to the point C we have another resistor. Whereas from E to the point C, here we have another resistor R. From the point D, where do we have? From. Right. So from the point D to the point C, we have another resistor connected over here. This one we are talking about. Okay? Mark it. So yes. So yes. This is another resistor. So 1, 2, 3, 4, 5 resistors are marked here. 1, 2, 3, 4, 5 resistors are being marked over here. And the point C, as you can see, it is being connected to the point B. Does it remind you of any particular combination of resistance? For me, one thing is coming into my mind. Yes, it is Wheatstone bridge, right? The combination of 5 resistance like this, Wheatstone bridge, we only have to check whether the given Wheatstone bridge is balanced or not. How will we check? We just need to check whether this equation is being satisfied or not. R1 by R2 is equal to R3 by R4. What is R1? R. R2 is also R. So R by R. What is R3? R and R4 is also R. R by R. Are they equal? Yes, they are equal, which means the given Wheatstone bridge is actually balanced over here. If it is balanced, we can remove the central one, right? If the center, this middle resistance is being removed, ho gaya to, we have this R and this R connected in series, hai na? So R plus R series kitna? 2R, right? So between the points we have R plus R, 2R, right? Similarly, ये R और ये R add कर ले, R plus R हो गया 2R. फिर भी ठीक है, जुम. ये हो गया 2R and connected like this, जुम. This is the point A and this is the point B. Now tell me, 2R and 2R in parallel. What is the equivalent value of resistance? We all know. R equivalent when n number of equal resistances are connected in parallel, R by n. Tell me what is the value of one single resistor over here? That is 2R, right? So 2R divided by number of resistances connected in parallel, that is 2. So ये हो गया R. Answer मिल गया या नहीं मिल गया? मिल गया. कितना है? R. So that is the final answer for this particular question. I hope you all understood. right? Yes or no? Yes or no? Are everyone just yell out in the class. Give me an amazing thumbs up out there, and do let me know that everything is clear to everyone here in this classroom. Is it clear? Good evening, Miss Abhirami. Okay, I missed every one of you also actually. Right? I think it's been almost a month, right? I've seen you all live over here, right? And I'm actually feeling so pretty good, so happy to see every one of you here, right? I'm in Noida actually, though I'm not supposed to say where I am, right? Okay, Abhirami, good, Evelyn. Okay. Now, Melganis can answer every one of you. Yes, I can actually see that smiling faces from everyone. आ गया समझ my old lines, right? My pretty old lines. Yeah. Actually, I also forgot that. आ गया, सबको समझ में आ गया, है ना? ठीक है. Yes. Anyway, let's move to another question from the part of potentiometer. I know that for many of you, potentiometer topic is a bit difficult topic, है ना? What do you all say? Do you say that the potentiometer is a bit difficult topic? And that's why I have actually used 2-3 questions from the part of potentiometer. ठीक है? Yes sir, please बताया मेरे को इन okay, ठीक है. So here we go. A potentiometer wire PQ of 1 meter length is connected to a standard cell of E1. I hope you all can see. So this will be actually forming the primary circuit. We all know primary circuit and secondary circuit is there in potentiometer. You all have learned it, right? Okay. Now another cell E2, which is the cell in the secondary circuit, E2 of EMF 1.02 volt is connected with a resistance R, okay, and a switch S, as you all can see, as shown in the figure. With such switch S open, matlab the switch S is open, matlab this circuit is actually open, current is not flowing in the circuit, right? Now if the current is not flowing in the circuit, whatever is being measured by the potentiometer, will it be potential difference or the EMF? It will be EMF, right? It is the EMF of the cell is actually measured if the current is not flowing, and if the current is flowing, it will be the potential difference that will be measured. So here in this case, it is the EMF that is measured. So I'll write it down. If anybody is having problem, I'll first write it down. It is EMF that is being measured. I'll write it here. EMF that will be measured when secondary circuit is open. Now, I think I don't need to write the other case, which means if the circuit is closed, obviously, it is a potential difference that is being measured, right? Okay. So, yes, let's continue. Open. The null position is obtained at a distance of 49 centimeters. Null point distance is 49 centimeters, okay? The potential gradient in the potentiometer wire is. This was one of the simplest questions, right? Null point length is given, right? EMF of the cell is actually given in the secondary circuit, right? Potential gradient. What is the simple formula? What is the simple formula? EMF in the secondary circuit. So I have written as ES. EMF in the secondary circuit is equal to lambda, which is the potential gradient, into L or X, whatever is the null point length, right? So it is given that the EMF in the secondary circuit is having a value of 1.02. Lambda is what we have to find out, and the value of L, which is null point length, is 49 centimeter into 49. So we are not going to convert this 49 into 0.49 meters because I'll show you the option once again. The answer is in centimeters. So don't make a mistake over here. Okay? Anyway, the value of lambda will be equal to 1.02 divided by 49 volt per centimeter once again. So this is going to be almost approximated as how much? 0.02 volt per centimeters, and yes, that will be the final answer. Oh, it's not V over there. I'll just erase it for you. Okay, it's the value of lambda we have actually found out, right? Okay, done, isn't it? Yeah, no song, right? Only studies. Only the best preparation for JEE happens here. Right? If we're all, I'm going to sing a song, I'll let you all know, okay? In the group. Okay, fine. So I hope the answer is clear to every one of you, which is 0.02 volt per centimeters, isn't it? Right? No more issues, no more doubts. Can we all go to the next question, everyone? If you are still active out there with full of energy, let me know how much energy you all have still now. Everyone? Hi, I also miss songs. I'm also missing the songs. Okay, don't worry. Okay, so I hope you all have marked the answers, right? I can show you the answers slide once again. If you want to take a screenshot, you all can do that. Jaldi se, fatafat, right? So no doubts, any doubts, anyone? Jaldi se jaldi fatafat bol dijiye. If you have any doubts, do let me know. Kuch nahi, everything is fine. Okay, I think the fire says everything is going awesome. Or if the fire says I'm using a red pen over here. If that's a poor joke, please let me know in the comment box. Okay, ठीक है. I'll start a separate channel for the songs over here. ठीक है? And I'll share it with you. Okay, anyway, here we have the next question over here. Again from potentiometer. As I have told you, it's a very important topic. At the same time, many of the students are finding it difficult. If you are not finding it difficult, let me tell you, you are super brilliant students. ठीक है? Okay, fine. Question goes like this. The length of a potentiometer wire is given as 1200 centimeters. Wow. And it carries a current of 60 milliampere, which means that the primary current, the current in the primary circuit, it's 60 milliampere. For a cell of EMF 5 volt and an internal resistance of 20 ohms, the null point on it is found to be 1000 centimeters. The resistance of the whole wire is. Anyway, I'll first give a small picturization to this entire question. This will actually help us understand how to deal with this problem in a very simple manner, right? Okay, so here we go. So first we'll draw the primary circuit over here. Okay, so this is our primary cell. Let me mark it as E, and it is connected to a wire. Okay, let me draw the wire with a bit of thickness. As you all know, I'm already bad in drawings. Okay, so what all is given about this particular wire? Okay, internal resistance null point is found to be, okay, so the wire is actually having a length of 1200 centimeters and it is having some resistance R which we don't know. Okay, now we have a secondary circuit, right? Secondary circuit has a cell of, let me say, E1 over here, right? It has an internal resistance and through a galvanometer it is connected to a jockey, and it says the null point length, the value of X is actually 1000 centimeter. One more thing, in the secondary circuit, sorry, in the primary circuit, the value of current is actually given as 60 milliampere. What else is given? What else is given? This is more than enough, I suppose. Yes, yes, yes. Okay. For a cell of EMF 5 and internal resistance, this is also given. This is also given 5, and internal resistance, how much is given? Right, 20 ohms. Right. So these are the values given. Question is to find out the value of capital R. Tell me, what is the simple basic equation we have to use over here? We simply have to use EMF in the secondary circuit is equal to lambda, which is the potential gradient, into the length. What length? The null point length. Let's start substituting the values. EMF in the secondary circuit, it's 5. Okay. Now tell me, what is lambda? Lambda is the potential per unit length. Total potential dropped across this particular wire divided by the total length. What can be the total potential dropped across this particular wire? The total EMF in the primary circuit, right? So let me put it as E itself, divided by total length of the wire, that is 1200, right? Multiplied by the null point length, that is actually 1000. Okay, now I'm not converting from centimeters to meters once again, because on the numerator and denominator we have the centimeter. Even if we make the conversion, it will get cancelled. You guys are super brilliant, right? I think I don't need to explain all of these things. Anyway, let's proceed with it. Now tell me, how can I substitute for this EMF E in this primary circuit? That is equal to net value of the current into net resistance. So let's say 5 is equal to, this 2 zeros goes 10 by 12, that is equal to 5 by 6 into the value of EMF in the circuit is equal to I into R. I is equal to 60 milliampere. That is 60 into 10 power minus 3 into R. Whatever we can cancel, jaldi se we can cancel. 5, 60 divided by 6, 10. 10 into 10 power minus 3 is 10 power minus 2. So R is equal to 1 divided by 10 power minus 2 ohms, which is actually equal to how much? 100 ohms. Very simple, right? So समझ में आ गया? This was actually a very good question, and it came for actually JEE Main 2020. So this is the level of questions you have to actually practice from this particular chapter of current electricity. I hope you all are getting right? That method or the level of the questions you have to practice, right? So don't go for very high level questions if you are planning for JEE main. These are the level of the questions, right? So if you know this much of concepts about potentiometer and from the chapter of current electricity, right, cracking JEE is not a big deal. Okay, so shall we proceed to the next question? If you are not giving me that energy in the chat box to me, right, there is no point of proceeding further. Yes or no? Am I saying right? Yes, I think I'm saying right. So jaldi se jaldi, fatafat, show me in the chat box how much energy you still have stored in the chat box, everyone. In the chat box, everyone. Everyone. Preeti, Evelyn, who all we have here? Right? Jaldi? Yes? Evelyn, awesome. So I think we can move to the next one. Yes or no? So I think you all have marked the answer to the previous one, that is 100 ohms, right? And do take a screenshot of the answers which we already have solved over here, right? And try to solve it again. And that will actually help you understand, right? Actually help you understand the actual methods and all the hidden concepts behind this potentiometer. Okay, Isha Agarwal, very good. I'm so happy to know that you also are solving the answers from there, right? Okay, all good. You know, JEE students, right? You will be learning this chapter, current electricity, right? And you need the concept of all these potentiometer for your board exam also. Don't think that only JEE students, only who are preparing for JEE can come and sit in the classroom and start solving it with me, right? We are not solving anything about Big Bang theories or anything of that sort of thing which is not useful, right? These all chapters are there for your examinations, right? Okay. Miss you. Arey, thank you, Paranav. 100% energy. Awesome. Preeti, Evelyn. Paranav, all good. Okay. So yes, moving to the next question over here. Actually, this is a pretty simple question. Okay, so here we go. In a building, there are 15 bulbs of 45 watts. Then 15 bulbs of 100 watts. वो भी बढ़िया. 15 small fans of 100 watts. अरे इतना बड़ा घर है कि क्या है ना? 2 heaters of 1 kilowatts. और क्या है? The voltage of electric main is 220 volt. The minimum fuse capacity of the building will be. What is the question here? What do you mean by minimum fuse capacity? Which means the minimum capacity a fuse should be having, or the minimum amount of current that can be passed through the fuse wire, or that should be passing through the fuse wire, is a question. Okay? So let us find out the minimum value of the current that should be passing through the fuse wire. And what does it depends upon? It depends upon what is the minimum current requirement in the circuit according to the devices available. How can we actually find that out? It's very simple. Now we all know the equation to power is equal to voltage into current, which means if you are calculating the total power that is being delivered to the entire circuit, that is equal to the net value of voltage into the total value of current in the circuit, right? Which means, as a question is to find out the total value of current in the circuit, we can actually rearrange it as total power divided by net value of voltage. Now, net value of voltage, finding that out is not a big deal. How much is it? 220 volt. It's given. We can actually directly substitute it as 220 volt. Not a big deal. Now, finding out this, isko hai thoda, okay? Though it's not a big deal also. That is the only thing that can stop anyone from getting the answers over here. Kaise? Array, we know that in our houses all the devices are connected in parallel. Okay, I'll say we'll have one device over here like this and its power is P1. Another device over here, let's say it is P2, right? Another device over here, let's say P3. Now tell me, if this is the case and this is how the devices are connected, tell me what should be the total power that has to be provided to the circuit. That's P1 plus P2 plus P3. Okay, we just have to add up the powers. So similarly, we have to add up all the powers according to the devices that is available in the circuit. Dekh 15 bulbs of 45 watts are there. So how much should be the total power that has to be delivered? 15 into 45. 15 into 45. ठीक है. फिर क्या है? 15 bulbs of 100 watts are there. So its power is equal to 15 into 100 plus. और कौन है? That is 115 small fans of 10 watts. अरे ये तो बड़ा घर है ना? बहुत बड़ा घर है ये. ठीक है. And 2 heaters of 1 kilowatt. So 2 into 1000 divided by कितना है भाई इधर? 220. right? So this is 220 volt, and if I do the calculation, we'll be getting the value of current as 20 ampere. Let's cross check it. Yes, it's going to be 20 ampere. So you just need to add up all the values of the power divided by the total voltage, and that will give us the net value of the current that should be provided, which means a minimum amount of this much current has to be given to all the devices in this particular circuit, which means the fuse should be having a minimum value of 20 amperes to let it pass through it, right? Which means even though a current of 20 ampere pass through this fuse, it shouldn't be blown off, and that's what it means. समझ में आ गया? अरे समझ में आ गया तो show me that 32 teeth, how many teeth we have, right? Whatever, it doesn't matter, right? Okay, show me that entire teeth and give me the smile over there. Okay, with the smiling faces, everyone. Is it clear? Those who haven't marked down, okay, those who haven't noted down the question answers over here, जल्दी से कर ले and do let me know. जल्दी 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 आपका स्वागत करने हम सब मिलकर आया है चेहरे पर स्माइल और चैट बॉक्स में फूल और धीर सारा प्यार लाए. अरे thank you so much. Though I have understood only 70% of what is being written over there, anyway, I'm so happy for that. ठीक है? Good evening, Asa. Good evening, good evening, good evening. Array, so many of my regular students and old students are over here. Okay, good to see every one of you in this under this platform. Okay, ठीक है, बढ़िया. So we are proceeding further. The answer is 20. I hope you all got it. ठीक है ना? So अगला question पे जा रहे हैं. And this is a question which came for JEE Main 2020. Let's solve it out. The current I1 in the given circuit is. Have you all marked where this I1 is? Mark किया ना? इधर है I1. So it is this particular current we have to find out. Now we don't know what is the potential difference across this 1 ohm resistor, right? Directly we don't know. But we know across this particular point, I'm going to mark this point. Tell me what the potential difference. It's 1 volt, right? Because between these points, if you check, it's 1 volt. Between these points, if you mark, the potential difference is V is equal to 1 volt, right? So actually we can find out the net value of the current passing through here. कैसे? Tell me. I is equal to 1 divided by equivalent value of resistance, right? So let's find that out. So yes, answer will be the value of I. We already have marked this as I. So I is equal to 1 divided by equivalent value of resistance. We can do the calculation of resistance from here itself. 1 and 1, right? In parallel. So 1 and 1 in parallel, how much is it? Okay, 1 by R is equal to 1 by 1 plus 1 by 1, that is 2. 1 by R is 2, so R is equal to half. Half plus 2, so 2.5 or 5 by 2. So this is equal to 1 divided by 5 by 2, that is equal to 2 by 5. So how much that is? 0.4. Which means the value of current passing through this is 0.4. अरे कितने सिंपल से हो गया? Is our answer 0.4? अरे बिल्कुल नहीं. हमारा आंसर कितना? आंसर कितना? देख ले, this 0.4 is actually going to divide as two different currents. But as the value of the resistances are equal, they will be divided in an equal fashion, which means 0.4 will be divided equally as 0.2 and 0.2. So I1 का value कितना? I1 का value हो गया 0.2. Isn't it? Simple सा. Simple, right? Hindi is so much improved. Arey wah. Amazing session. High voltage. Arey, thank you so much, Manu Rai. Okay. Thank you so much. Thank you so much. So, the value of the current passing through this particular circuit is 0.2. Now, you just think about all the questions that we have done till now. Right? Which means all the questions that we have done till now is very, very simple, nannu munnu questions. So, this is the level of the JEE. Matlab, if you know the concepts till now, okay, these kind of concepts, if you know, awesome, you are well and good. Okay, so keep yourself motivated, have that smile on your faces every day when you wake up, okay, and before you start your studies, and even after you, at the point of ending your study, that smile should be there on your faces. ठीक है? So yes, answer तो clear है ना? ठीक है? Shall we move to the next question? हम तो जा रहे हैं. Answer तो आप लोग mark किया ना? 0.2 answers also. I think you all made a screenshot so that you can do it later, right? Okay. So this question. This is, I think this is one of the pretty big question over here. Anyway, no worries, right? However big the question is, small the question, it doesn't matter for all the JEE aspirants over here, right? All the students of Extramarks, it doesn't matter. We're going to solve it anyway. ठीक है. In the figure shown, the current in the 10 volt battery is close to. right? Which means what is the value of the current passing through this 10 volt? Is it a single branch circuit? No, we have two branches are there, right? So it's a bigger circuit. So here which laws we have to actually use here? Kirchhoff's first law and Kirchhoff's second law. ये दोनों use करके solve करना चाहिए to find out the value of current through 10 volt. So yes, do the first part, which is applying Kirchhoff's first law, which is distributing the current in each and every branch. Let's start. So let's start with the current I over here, which is the current we have to find out. ऐसे इधर आकर let's say that the current is splitting into two. Let's call this current passing through these branches. I1, tell me, देख ले, to the junction I is coming, to one of the branch I1 is going. How much will be this current? From I1 is going, so remaining will be passing through this. So I minus I1 हो गई बात, ठीक है? करना क्या है? Now we just need to know that in closed circuit, the net value of voltage is equal to V net over the closed circuit is equal to 0. Kirchhoff loop rule. Starting from this point, okay, start moving through the circuit. Starting from this point, moving from negative to positive. Tell me what will happen to the potential difference. There will be a positive potential difference plus 10. Okay. So moving. We are moving through this ऐसे, ठीक है? ऐसे जा रहे हैं. Now tell me, we are moving in the direction of the current through a resistor. Will there be a potential difference drop? Yes, a potential will be dropped. So this will be coming with a negative, and potential drop is equal to I into R. What is I? I minus I1 is a current passing through that, and the resistance is 10 ohm, right? Okay, फिर हम continue कर रहे हैं, and through this 4 ohm, how much will be the current? Through this circuit, it's I. So that is minus 4I. Once again, Y minus, we are traveling in the same direction. So rearranging, plus 10 minus 10I minus 4I is minus 14I. If you take it to the right hand side, that will be plus 14I. Minus of minus plus 10I1. If you take it to the right hand side, minus 10I1. And on the left hand side, we have 10. And if you cut it by 2 once again, this will be equal to 5 is equal to 7I minus 5I1. First set of equation, right? I hope you all got it. Now let us move to the second part. And how are we going to travel? Starting from the first point, ऐसे. Okay. So again, applying net value of the voltage is equal to 0. Starting from here, moving from negative to positive, there is an increase in potential plus 10. Moving, look at the tip of my pen, moving, we are passing in the same direction of the current through a resistor. There will be a potential drop, so minus 5, what is the value of current? I1, okay. Again moving from positive to negative, so potential drop, minus 20. Again moving in the same direction of the current through a resistor of 2, so minus 2, what is the value of the current? I1. Again moving through this 4 ohm resistor, so in the same direction, so minus 4. Current through this particular branch is I, and that is equal to 0, right? Okay. What is left? Just to rearrange the values. So this is 10 minus 20 minus 10, right? We have minus 4I. Okay, then minus 5I1 minus 2I1 minus 7I1 equal to 0. Rearranging, minus 10 is equal to 4I plus 7I1, that is second circuit. So we have two equations over here. One is 5 is equal to 7I minus 5I1, minus 10 is equal to 4I plus 7I1, that is the second equation. How many unknowns we have? We have two unknowns. How many equations we have? Two equations. Can't we solve it? Yes. So now if we solve, I'm leaving this solution. I think you all know to solve x and y from two basic equations, right? So I'm going to leave it to every one of you, and once you solve it, you're going to get the value of the current I as 0.21 negative ampere. Now tell me, what does this negative value of the current means? It simply means, actually we have considered the direction of the current upwards, right? So here, as there is a negative, it simply tells, the answer tells that the direction of the current is actually opposite to whatever you have considered, which means the current is actually moving in which direction? In the downward direction, and the value is 0.21. Okay, so what can be the answer? 0.21 from positive to negative terminal. As you can see, from positive to negative terminal, and that will be the answer. मिल गया तो मिल गया, आंसर सबको मिल गया, right? Yes. Now tell me, those who haven't copied it down or those who want to take a screenshot, जल्दी से zoom, जल्दी से कर ले, जल्दी फटाफट. You all can do it, right, Preeti? That's the spirit. I know that you all will be doing. All of you are my super amazing, super great, super brilliant students, right? So तो कर जाएगा. Okay, Evelyn, awesome, sure. So we have one more question. Shall we do it? Everyone, let me see some energy. I'm the person who was talking for the past 45 to 50 minutes, right? And I think by looking into the chat box, I think you are the people who are like totally tired like this. ऐसे बैठ रहे सब. I'm the बिल्कुल बढ़िया. And why the... Okay, Jia, hi. I'm so good actually. Good to see you over here, right? Okay. To the very last question. There's also a question from Kirchhoff law. And you also know how important Kirchhoff law is, right? So let's do it and yes, wind up the session after this. So the question is in the figure circuit diagram, the current I1, I hope you all can mark I1 over here, right? I1 is equal to how much? Minus 0.3. I4 is 0.8. I5 is equal to plus 0.4. As following the current I2, where is I2 over here? This is I2. Okay. So here we have I3 and I6. So these are the currents we are asked to find out. Very simple. Shall we do it? Now they click. I6 is very simple. I5 is the current passing through this branch. As the branch is not moving, as it is not distributing, as the branch is not distributing, it's the same current which passes through this resistor and this resistor, right? Obviously, you can see that the current is not getting distributed. So whatever is the value of I5, same will be the value of the current I6 also, yes or no? So I can write the value of I6 will be equal to the value of I5, and what's the value of I5 given? 0.4. मिल गया तो मिल गया, आंसर तो मिल गया. अगला क्वेश्चन कौन है? अगला क्वेश्चन तो ये है कि okay, so I4 we have, which is the amount of current coming into the junction. From the junction I5 and I3, we know the value of the current coming into the junction, that is I4, is equal to the current leaving the junction I5 plus, which is this current I3. I hope you all can see. I4 का value 0.8. I5 का value we already know 0.4. I3 का value हमको पता नहीं. So I3 का value हो गया 0.4 amperes. Done. So क्या हो गया? I6 हो गया, I3 हो गया, बाकी क्या है? I2 है. For that, let us look into this junction. Tell me which are the currents coming into the junction, I6 and I3. So the sum of the currents coming into the junction is I3 plus I6 equal to, what is the current leaving from the junction? I2 and I1. So current coming into the junction is equal to current leaving the junction, I1 plus I2. हो गया. Substitute the values. I3 0.4. हमारा पास तो है. I6 का value also 0.4. Oh my god, I can't bend more than this. 0.4 is equal to I1 का वैल्यू हमको पता नहीं है, I2 का वैल्यू पता है क्योंकि I1 का वैल्यू दे दिया है, I2 का वैल्यू हमको पता नहीं है. तो कर क्या, अरे इधर तो चेंज करेगा ना. सो I2 हमको नहीं दे दिया, I1 का वैल्यू दे दिया माइनस 0.3, उधर ही चेंज किया है. बस हो गया. 0.4 plus 0.4, 0.8. If minus 0.3 come to the left hand side of the equation, plus 0.3. So 0.8 plus 0.3, 1.1, and yes, that is our final answer. हो गई बात. And that was the very last question of today's class. जल्दी से जल्दी फटाफट in the chat box tell me how was the session. Everyone just yell out and tell me how was the session मेरा बच्चा लोग. हाँ? अरे welcome to the class Reva. How is it? How do you pronounce the second part? Pernolia. I hope I have pronounced in the right way, isn't it? Right? Yes. Yes, so yes, Jia, I'm also super excited to see every one of you. Many of my regular students came here and I'm so happy to see every one of you. And it's the first option which is the correct one. Okay? So I hope you all have marked it. Now if anyone is concerned about how your JEE examination is, how to make a proper preparation, what all questions you need to solve for the upcoming JEE examination, don't worry. What you just need to do, either go to the Google Play, or if you are super rich, you will be having an Apple phone, so just download it from the Apple Store. What do you have to download? Extramarks app. Okay, so yes, jaldi Extramarks app, the learning app, download it and start solving the question, because you will get tons and tons of questions to practice from there, and those questions are more than enough to get you into the dream NITs and IITs. right? So I think you all want to join to either of the NITs or IITs, right? So yes, questions are waiting for you. What you all need to do is to take up the decision and to start working for it, right? And I know that what you all are thinking, when is going to be the next session, right? From the chapter of moving charges and magnetism, we'll be meeting at 16th May. I know it's a bit far. If I can make it a bit short, I'll let you know. Okay? The class will be happening at 6:30. So yes, I'm going to sign out. Every one of you, till we meet next time. Bye everyone. Take care and don't forget to subscribe to the channel, okay? And click on the bell icon. So once again, bye everyone and good night.